So we were discussing this question in the earlier class. Let's move forward. Let matrix B be the adjoint of a square matrix A. So the adjoint of A matrix, let's wait, my laptop is not responding. The adjoint of A matrix is B. Let L be the identity matrix of the same order as of A. So let's consider that A matrix is of 2 by 2 order. So there's an identity matrix L of 2 order. Okay. And if K is the determinant of matrix A, okay, K is the determinant of matrix A. Now what we have to find out? A into B. So A is A and B is adjoint of A. Now we know its formula is the determinant into the identity matrix. The determinant of matrix A is K and identity matrix is L. So B should be the answer. Any doubt anyone?
No, sir.
Okay, so let's move ahead. You have to find out the inverse of this given matrix. So we know inverse of any given matrix. We have to find out the adjoint of the same and the determinant also. So in every option, there is some matrix given. So let's first find out the determinant. And if the determinant comes out to be 0, that is, if the given matrix is a singular matrix, then the inverse will not exist and D will become the right answer. So let's check the determinant. 1 into 3 into 6, 18, minus 4 into 4, 16, minus of 2, 2 into 6, 12, minus 3 into 4, 12, plus 3, 2 into 4, 8, minus 3 into 3, 9. This is plus of 2, this is 0, this is minus of 3. 8 plus 8 minus 1, minus of 1 into 3, minus of 3. This becomes minus of 1. So the determinant is non-zero, means it's A is a non-singular matrix, hence its inverse will exist. Okay, so let's now find out the adjoint of the given matrix. So for finding out the adjoint, we will simply write the matrix. So the given matrix is 1, 2, 3, 2, 3, 4. So let me utilize the space. 1, 2, 3, 2, 3, 4, and 3, 4, 6. Okay, let's so this is the given matrix. Cool. So copying the first two columns and repeating them once. Okay. Now copying the first two rows and repeating them twice. So now this is a 5 into 5 matrix. But we have to cross the first row and the first column. Now what will we do is we will find out the first element by cross multiplying and subtracting. 18 minus 16 becomes 2. 12 minus 12 becomes 0. 8 minus 9 becomes minus of 1. 12 minus 12 becomes 0. 6 minus 9 becomes minus of 3. 6 minus 4 becomes plus of 2. 8 minus 9 becomes minus of 1. 6 minus 4 becomes 2. 3 minus 4 becomes minus of 1. Now this is not the adjoint. Its transpose is the adjoint of given matrix. Cool. So now we have the adjoint. So the inverse will be 1 by A matrix, A determinant, which was minus of 1 into the adjoint of this. So the first row will become the first column, second row will become the second column, third row will become the third column. Now 1 upon minus 1 is simply 1 upon, is simply minus of 1. So minus 1 will get, uh, you can say divide, or you can say multiply the same. So instead of doing all this, let's just look on the options and do it faster, right? Let's observe the options, and they should be having minus of 2, 0, and plus 1 in the first row. Minus of 2, minus of 2, 0, and plus 1. So this is the option, correct option. Is that clear, everyone? Any doubts? No doubts?
No, sir.
No, sir.
Please be very attentive. Otherwise, I'll make a rule of turning on the cameras. Be very attentive. It's your life. Okay. So let's now discuss about a few special types of matrices. First, talking about orthogonal matrix. So when the product of matrix and its transpose becomes equal to the identity matrix of same order as of A, then that particular matrix will be known as orthogonal matrix if the matrix is satisfying this condition. As simple as that. Any doubts, anyone? Any doubts?
No, sir.
Okay. So let me repeat a basic thing about multiplication of matrices. If let's say AB is equals to C, D, okay, where A, B, C, and D are matrices. So if we have to multiply, let's say X matrix on both sides, so we can do it in two ways. We can multiply X matrix, multiplication of matrix X on both sides can happen in two ways. One is we can pre-multiply it. Pre-multiply means we'll multiply X, pre the left hand side and pre the right hand side. Or we can post multiply something in the equation. So we'll multiply AB post X, CD post X. Clear, everyone?
No.
Is this multiplication?
Yes, sir.
Okay. So now let's solve this for furthermore. So A into A transpose is identity matrix. So let's multiply the inverse matrix of A, and let's do it. Let's do a pre-multiplication. So we'll multiply A inverse priorly. Here also A inverse into identity matrix. Now A inverse into A will make it an identity matrix into A transpose. A inverse into identity matrix will be identity matrix itself. Identity matrix multiply when it get multiplied to any other matrix, so it is equivalent. It is equivalent to the same matrix. So A transpose is equals to A inverse in orthogonal matrix. You need not remember it. Just learn it. It's for sure. Like it's enough. I've just represented and solved a previous year question here in front of you. That's how we can use pre and post multiplication to understand some. more things. We'll be solving the same previous equation add. Let's now discuss about idempotent matrix. So this matrix is itself saying that I am potent matrix. Means that when you raise any matrix's power, when you square any matrix, so the answer will be the same matrix. When this condition is satisfied, that particular matrix is known as idempotent matrix, and you can learn this by using that it is saying I am. So after squaring, the matrix is going to become I only. Okay. So this is a case of idempotent matrix. This is a multiple time repeated previous year question where AB, it will be given to you that AB matrix is equals to A and BA matrix is equals to B. So here A and B matrices are idempotent. So if they are idempotent, so means A square will be equal to A and B square will be equal to B. Clear everyone? Clear any doubts about idempotent matrix or orthogonal?
No, sir.
No, sir.
Great. So let's now talk about nilpotent. Now here the name is itself saying nil means zero. So when you raise a matrix power to its order, then the matrix becomes zero. Then it will then the matrix will be called as nilpotent matrix. Where remember K is the order of matrix, and these all matrices conditions will only be satisfied if they are square matrices. Involuntary matrix, now it is itself saying IN means identity matrix. When you square any matrix and it comes out as an identity matrix, so that particular matrix is known as involuntary matrix. As simple as that. So there are tricks to remember it, and orthogonal is the only left property which you have to learn by yourself, and it's very easy. Please read this page, and if you have any doubts, read. Done?
Yes, sir.
Any doubts, anyone?
No, sir.
Okay, let's move ahead. So this is the question. It is given that A and B are two matrices such that AB is equals to A and BA is equals to B. Then we have to find out B square. Now we know when such conditions are true, then they are what? Which kind of matrices? Idempotent matrices, both A and B. So B square will be equal to B. We have just discussed this here, right? Anyways, but still, let's discuss one more method. Let's solve it using one more method. No, not a good idea. Let's use one more method. So it is given to us that AB is equals to A and BA is equals to B. So let's now square the first equation. This becomes BA square means, and B square. BA square means BA into BA, simple, equals to B square. Now we observe, what is this? AB, AB is A. So B into A, that becomes BA square. Okay, cool, cool. So instead of writing BA square, let's write BAA, because we'll keep on simplifying it. So now we know BA is what? B. So this becomes B. This becomes B. This remains A. Now we know what is BA. This is B itself. So B is equals to B square. This is how also we can solve, and option A will be the correct answer. So there are two methods for solving this equation. If you are aware that these are idempotent matrix, so directly mark the answer. Otherwise also, if you are smart enough, you'll also solve in 20-30 seconds. Any doubts, anyone? No doubts?
No, sir.
Okay. A square matrix A is called orthogonal if. Okay, so let's discuss about orthogonal matrix first. And in the options we have observed, we have to find out A on one hand side. Okay, so A into A transpose is equals to I, then only square matrix is going to become orthogonal. Okay, so let's do one thing. Let's what is our objective? To make A on a single hand side. So let's do one thing. Let's multiply. Uh, okay. So in all the options, there is A on one hand side. And in this particular option, there's a A transpose in one side. So we'll do the same. First, we will multiply, pre-multiply by A inverse. So pre-multiplication by A inverse on both sides. So A into A inverse becomes A inverse into A transpose into A inverse into I. Now identity matrix got getting multiplied to anything that remains the same. A inverse into A becomes identity matrix into A transpose. That becomes A transpose only. Okay, A transpose is equals to A inverse. Okay, is this matching with any option? Yes, B option. Otherwise, if it would have not matched with any other option, then we would have tried post multiplication of A transpose inverse, and then we have solved for something. And now we know it's not going to match with any option because we have already found it out the correct option. Any doubts, anyone?
No, sir.
Okay, great. So let's move forward. Now there's a given matrix and we have to find out whether this matrix is singular, involuntary, or nilpotent or idempotent. So first tell me what is a singular matrix? If this condition is getting satisfied, then A matrix is singular. If A square is becoming identity matrix, then involuntary matrix. If A square is becoming an sorry, A raised to power its order, which is 2 by 2. So A square is becoming null matrix, then it will be in nilpotent matrix, and it will be an idempotent matrix when it will become I. So when A square is remains as A, then D option will be. Now let's find out what is the case with A. So finding out the determinant 0 into minus 1, so it's minus 1. Okay, it's not a singular matrix. In volatility, let's find out a square because there is a square in every condition. So for finding a square, we'll write the matrix twice. First row, first column, 0 into 0, 1 into 1. First row, second column, 0 into 1, 1 into 0. First row, second column, 1 into 0, 0 into 1, 0. Second row, second column, 1 into 1, 0 into 0. This is A square. Now this is the identity matrix of two order. So B is the correct option. It's an involuntary matrix. Yes. Any doubts, anyone?
No, sir.
Yeah. So please observe all the options and what are the conditions and how we have solved. How the multiplication happened. First row, first column, then first row, first row, first column for this element, first row, second column for this element. Sorry, yes, yes. First row, second column. Now second row, first column, second row, second column. Done reading?
Yes, sir.
100% sure? Sure? Done?
Yes, sir.
Okay. Now, Guru Charan, please unmute yourself and tell me what is a singular matrix? Yes, Guru. Okay, Rishi, what is a singular matrix? Okay, Yarini, what is an idempotent matrix?
Sir, can I say what is singular matrix, sir?
Yes, Guru.
Sir, it has a determinant with 0, sir.
Okay, and what about nilpotent matrix?
Sir, nilpotent matrix, sir.
Ah,
Sir, it gives the same matrix, like
which one?
in independent matrix.
Yes, right.
It means idempotent.
Yes. Yes, Guru, what is a nilpotent matrix?
Sir, where a square matrix where the product of the matrix will itself is a null matrix, sir.
Okay. Okay. What about involuntary matrix, Guru? Okay, I'm glad that you answered everyone. Even if it was wrong, then it is also okay. But you answered correctly. That increases my
Sir, can
gratitude.
you say what is involuntary matrix again, sir?
Okay, no problem. So whenever this is condition. Okay.
Okay, sir.
Mm, Where are the conditions? Let's move ahead. Discuss the next. Okay. So this is the finish of matrices chapter. I guess. Let me see if there are some miscellaneous things also which are needed to be added. Till then, if you have any doubts, you may ask. No doubts, anyone?
No, sir.
Okay. So I guess we have already discussed about how many minimum number of zeros in diagonal matrix. We have, right? These will be n number of elements. Total number of elements will be n square, right? So n square minus n will be the minimum number of zeros. We have already discussed, I guess. Do anyone remember? No one remembers? Minimum number zero in diagonal matrix. Just write this if you not remember after this class. They are not in the notes. Okay, anyways. Things to add. Some properties of adjoint I'm repeating. Okay, so properties of adjoint A into adjoint of A is equals to determinant of A into identity matrix. Now, this has come from A inverse formula, which is equals to adjoint of A divided by modulus of A. So simply, if we bring the modulus of A to first of all, let's multiply it by A on both sides. So A into A inverse makes it I, and A here because there was a pre-multiplication on both sides. Let's bring the determinant of A onto the left hand side. So determinant of A into I is equals to A into adjoint of A. Now this was the pre-multiplication of A. This could also be post-multiplication. There could also be a post-multiplication of A. So A inverse into A, identity matrix, and adjoint of A into A divided by modulus of A. Now modulus of A into identity matrix equals to adjoint of A into modulus into A. So from this observation and this observation, we can conclude that that the A into adjoint of A is equal to modulus of A into I, and it is also equal to adjoint of A into A. So basically what we are seeing that the multiplication of a matrix and its adjoint is commutative in nature. They are both equal. Here these both are the properties, but still they are equal. So this is what we are trying to say. And this is important. Clear, everyone? Any doubts?
No, sir.
No, sir.
Okay, so let's move ahead and discuss some more properties. Now, this is some content which is not there in the textbooks, but is observed from previous year questions. That's why it's been taught to you. So of adjoint A is modulus of A raised to power n minus 2 into A. Okay, and if we take determinant of any adjoint, so that's one property of adjoint of A, that becomes modulus of A raised to power n minus 1 this time. Okay, and modulus of adjoint of A is modulus of A raised to n minus 1 whole square. And generally we can write there is adjoint of SSS adjoint of A, and this is happening m times. Like there was adjoint only one time here two times, where the adjoint is happening on the adjoint particular. We are considering the adjoint, finding the adjoint of A for m times repetitively. So this is equivalent to A modulus of A raised to power n minus 1 raised to power m. Here, okay. Move. Clear, everyone?
Yes, sir.
Yeah. Let's move to more properties of. We have to find out the adjoint of a matrix with whom there is a scalar in multiplication. K is a scalar, means a constant. So this will be equal to K raised to power n minus 1 into adjoint of A, where K is a scalar, a constant, like 1, minus 1, 2, 3, 4. The adjoint of A transpose is equal to the adjoint of A's whole transpose. Clear? Any doubts, anyone? And similarly, it's the same like adjoint of any A raised to power n. N can be any power. It is equivalent to adjoint of A's power, which is n. Please read. If there's any doubt in understanding these properties, please let me know. Any doubts in understanding these properties? No doubts? Yes, please respond. Any doubts, anyone? When students don't respond, I feel my internet is gone. Something. Moving on to the next properties. Reversal load adjoint of AB is equal to the multiplication of adjoint of B into the multiplication of adjoint of A. adjoint of diagonal matrix is that diagonal matrix. Clear. These are some properties. Okay. We'll discuss more in determinant chapter 2. Okay. Shall we conclude the class, like the discussion of matrix chapter? Shall we move on to solving the previous year questions of matrices?
Yes, sir.
Everything clear?
Yes, sir.
This chapter is really easy. Just learn it properly. Just learn the properties, and then you'll be
So
able
can
to.
you send a PDF like yesterday, sir?
For sure. For sure.
Thank you, sir.
Okay. Time to solve some previous year questions from the matrices chapter. First question. So this is a matrix given. A is equals to 1, minus 1, and 1. Now we have to find out this the value of this expression a cube minus 2a square. Okay, so we need to find out a cube and square. So first we'll find out a square, and then we'll multiply a square with a to find out the cube. Okay, simple. So a squared, writing the matrix twice. First row, first column. 1 into 1 minus 1 into 1 makes it plus 1. So 2. 1 into minus 1, minus 1 minus of 1. So 1 into minus 1, minus 1, minus 1 into 1, minus 1. So minus of 2. Similarly, minus 1, minus 1, minus of 2. Similarly, 1 plus 1, 2. So if we observe, if we take 2 common here, so it becomes 1 minus 1, 1. So this is equal to A matrix. So the A square is equals to 2A here. Okay. If it is so, let's find out A cube by multiplying A cube on both sides. So by multiplying A on both sides, post multiplication. So 2A into A becomes A square. Now we know from equation number 1, A square is 2A. Okay, cool. So now A cube is what? A cube is now equals to 4A. Okay, cool. So what we need to find out is A cube, okay, minus 2A square. A cube is 4A minus 2 into A square is 2A. Now our answer should be 4a minus 4a, which is equals to null matrix. Clear? Any doubts, anyone? Any doubts?
No, sir.
No, sir.
So here, please be aware about what you are solving. So you'll be able to solve the question fast in less steps. Okay. See, in NDA paper, time is very crucial. So there are some steps to solve any question. I'm not saying you to learn cubes and tables till 50. No, just simply read the question carefully and completely, and uh, read question and all options as well. Okay, I'll say better word is to observe. Okay, after reading, now think for a faster solution. Now pick one method which you can use for fasting, so solving fastly, then solve deliberately without any hurry with faster method. Faster method means assuming it can be hit and try or value putting or uh, using options and solving partially. Using options and solving partially. Okay, I will try to use this pattern, but this is important. You can take a snapshot right now. Please do it.
Taken, sir.
Done, sir.
Okay, great. So this is a given matrix. So we'll try to follow the same pattern that I have just drawn. So there's if A is a given matrix of order 3 into 2. There's another given matrix of 2 by 2, okay, 1, 2, 2, 1. Then which one of the following is correct? Okay, now we have to read the options. Okay, both AB and AB and BA exist. Neither AB nor BA exist. AB exists, but BA does not exist. AB does not exist, but BA exists. So after reading and observing the question and the options, we have made a conclusion that we are discussing about the existence of AB and BA. So for that, we'll only be discussing about the order of AB, about the A matrix and B matrix. So if AB is getting multiplied, 2 and 2 are equal. Okay, so yes, if these two are equal, so AB will be existing. Now let's discuss about BA. So 2 by 2, B matrix, A is 3 by 2. Now 2 and 3 are not equal. So only AB will exist. AB exists, but BA does not exist. Answer should be C. Yes. So this is how you can solve easily and fast. Clear, everyone? And now, if you haven't read the question and options properly, then you will be solved for AB complete matrix. You will form it. BA you will try to find, and you will see that there is no particular matrix existing. So that will consume a lot of time. So instead of that, focus on what is asked in the question and what is the fastest way to solve it. Clear?
Yes, sir.
Okay, great. So let's move ahead. Consider the following in respect of a non-singular matrix of order 3. Given A into adjoint of A is equals to adjoint of A into A. We have already discussed this particular statement earlier, right? When we have find it out that the A into adjoint of A is equals to modulus of A into I. And it is the same for this also, because the root of the of this these results, what, that A inverse is equals to adjoint of A divided by A determinant. So we can do two things, that we can pre-multiply A and we can post multiply A. So when we will post multiply it, then A in, adjoint of A. Okay, so let's do it. Let me do it once again. A inverse into A is equals to adjoint of A into A divided by determinant of A. So this has become I into determinant of I, adjoint of A into A. And when we will multiply A pre, then A into A inverse. Now A into adjoint of A divided by determinant of A. This becomes I. This becomes modulus of A into I. A into adjoint of A. Now, these two equations have same left hand side. So the right hand side must also be equal. That's why you can say first statement is correct. Now talking about the second statement, this is completely incorrect because we know adjoint A's determinant should be equals to determinant of A raised to power n minus of 1. Now here the given order is 3. So n will be 3 minus 2. So it should be 2 here. Then only the statement will be correct. But it's not there. That's why we'll see the second statement is incorrect. The second statement is incorrect. So 1A is the correct option. Any doubts, anyone?
No, sir.
No, sir.
Okay. So if A is a matrix of order 3 into 5 and B is a matrix of order 5 into 3, then the order of A, B and B, we only have to talk about the order. So let's write A is having 3 into 5 order and B is having 5 into 3 order. 5 and 5 are common, 3 by 3 is left. So AB matrix will be of 3 by 3 order. So 3 by 3, okay. So the B and D options are cancelled. Now let's talk about BA. So B matrix is of 5 by 3 order, A matrix is of 3 by 5 order. 3, 3 cancels, 5 into 5 is remaining. So C option should be a correct answer. Yes. Any doubts, anyone?
No, sir.
Great. Oh, these are all previous year questions. That easy questions, right? Very easy questions are asked from matrices. Okay. Okay. So one more concept left about Hermitian matrix and skew Hermitian matrix. So they're somewhat same like symmetric and skew symmetric matrix, but the only change is because of the presence of complex numbers inside the matrix. So whenever there is any matrix A whose transpose, sorry, whose transpose and also whose conjugate, we know what is a conjugate in complex number. The conjugate of x plus iota y is x minus iota y. So the conjugate of any matrix and its transpose is getting equal to matrix A, then A is known as Hermitian matrix. Let me try to give an example. It's the same. Okay, let me just randomly tell, let's say A is a matrix having 1 plus iota y, 1 plus iota and 2 minus iota here, and iota and minus iota here. So let's find its conjugate first. For finding its conjugate, we are going to do one thing simple, that we are going to change the sign of imaginary part of complex number. So 1 plus iota becomes 1 minus iota, iota becomes minus of iota, minus iota becomes iota, 2 minus iota becomes 2 plus of iota. Okay, now we'll take the transpose of the same. So 1 minus iota, minus iota, first row becomes the first column. Second row becomes the second column. Okay. So now, if this is equal to A, then only it is going to be known as Hermitian matrix. Is it the case that is it equals to 1? Is it equals to A? No, it's not the case. So this is not a Hermitian matrix. Let's take one more example. Nice. Okay. Um, let's take one more example. Okay. Now let's find out the conjugate, which is, now there's no imaginary part here. Imaginary part sign changed. Now let's take its transpose. 1 minus iota, iota 1, 2. Okay. So is this equals to A matrix? Yes, it is. So now here A matrix is a Hermitian matrix. Any doubt, anyone? That what is a Hermitian matrix? Basically, any matrices conjugate and transpose is equating to its own matrix, then it is a Hermitian matrix. Any doubt, anyone? Should I explain more or should I repeat?
No, clear, sir.
Okay, great. So keep one thing in mind, that conjugate of any matrix is simply that when we will change the imaginary part of every complex number that is there in the matrix. Simple. And as it is the case with skew symmetric matrix also, so it is a similar case with skew Hermitian matrix, that the transpose of any matrix the conjugate of any matrix whose transpose is becoming negative of the given matrix, then the matrix will be known as skew Hermitian matrix. Here A is the skew Hermitian matrix. A is the skew Hermitian matrix. Let's move forward and solve this example, solve this question. So given matrix is A, 1 minus iota, iota, and minus iota, 1 minus iota, where iota is the imaginary unit. Okay, then which one of the following is correct? So we are talking about A being Hermitian, skew Hermitian, or A's conjugate and transpose plus A becoming Hermitian or skew Hermitian. So let's now first discuss about the conjugate of A's, which will 1 plus iota, minus of iota, iota, 1 plus iota. Basically, what we have changed the sign of imaginary number, imaginary part of complex number only. Okay, so let's take its transpose also. So first row becomes the first column, second row becomes the second column. So is it equals to the given matrix? Is it equal to A? Can anyone tell me, please? Hello, everyone. Yes, yes, we will take the break after discussion. Okay. Now, please tell. Is this equal to the given matrix A or not? Nandana, Yarini, Guru Charan, Rishi. I am asking a simple question. Is this matrix equal to A, which is given this matrix, or no? Simple question. No, it's not
No,
because of
No,
sir.
sir. It's not equal.
the sign here.
Yes.
Yes. So it's not a Hermitian matrix. Let's check for a skew Hermitian matrix. For that, it has to be equal to the negative of A. So let's find out minus of A. Let's change all the signs. Is it equals to this? Yes or no? Yes or no?
Yes.
Is this matrix equal to this or not? Please speak. No worries, and don't be afraid to give wrong answers. Please don't be afraid of failure. And this is just practice. This is the learning phase. If you don't do
No,
mistake,
sir.
No, sir. It's not equal.
no, it's not. It's not. So we have to discuss about other options. We have already find out the A's conjugate and the transpose, which is here. First, let's add it with A. Okay. So adding A with this. So A's conjugate and transpose plus A. Now 1 minus iota plus 1 plus iota. So plus iota minus iota cancels. 1 plus 1 becomes 2. Iota plus iota becomes 2 iota. Minus iota minus iota minus of 2 iota. 1 plus 1, 2. Minus iota plus iota 0. So let's now, and now this is the new matrix which we have to talk about. Let's name it C for our convenience, or B. Okay. It is just for the sake of our convenience. Okay, so let's make more space for the calculations. Okay, now we will call this as B. This is B, which is a matrix 2 to 2 iota minus 2 iota and 2. Now let's find out its conjugate. And no imaginary part. Yes, imaginary part. Imaginary part. No imaginary part. Now let's find out its transpose. Let's convert this first row to first column, second row to second column. Okay. Now, is this equal to the given matrix? Is this and this matrix are equal or not? 2, 2, plus 2 iota, plus 2 iota, minus 2 iota, minus 2 iota, 2 and 2. Yes, they are equal, right? Because
Yes, sir.
corresponding elements are equal and order is also the same. So we may say B is equals to B's transpose, B's conjugate and transpose is equal. So B is a Hermitian matrix. So C should be the correct answer. Any doubts, anyone?
Sir.
Okay, great. C. A square matrix M is said to be Hermitian or self-adjoint. Hermitian matrix is also called as self-adjoint. If it is equals to its own Hermitian conjugate, that is this. This is the condition. Okay, then they have solved it. Any doubts, anyone with the previous question? Any doubts? Or should I repeat the complete question? However you say. Please, any doubts? Should I repeat?
No, sir.
No. Okay, let's move ahead then. So the next question, for how many values of K is the given matrix singular? So for a matrix being singular, we have to find out and it is given to us that is the matrix singular. So we need to find out the values of K because there is a variable in the matrix. So we are going to equate the determinant of the given matrix equal to 0, and then we'll be discussing about the values of K. Okay. So do you need a break or shall we continue? Okay, I guess no break is required. Everyone is silent. You can ask for it for 2-3 minutes break maybe. Or should we continue? Okay, let's continue if you want to respond. We need to find out the number of values that K will be having. Okay, so its determinant is going to be 0. So simple, its determinant is going to be 0. We'll modify the paper like this, and 0 will be having anything, doesn't matter, it's going to become 0 only. Minus of K into minus K into minus 1 becomes K minus 5 into minus K becomes plus of 5K plus 4 into minus K into K becomes minus of K square minus 0 into 0. Okay, doesn't matter. So this is given as 0. So this is 0 minus of K square plus 5K square. Okay, minus of 4K square. 0 is equals to 5K square minus 5K squares becomes 0. So we are not able to find out any value of K. So means for any value of K, this matrix is going to become singular for sure. So we can put any value of K means the domain of K is real number. Extremely sorry. Yeah, so we can put any value of K. So the domain of K is real number. So D should be our answer. Any doubts, anyone?
No, sir.
Okay, great. So look on the question. Let's look on the solution. They have done the same. Hence, for all values of K, the given matrix is singular matrix. Let A is a 2 by 2 matrix, x plus y, y, 2x into x minus y. B is a 2 into 1 matrix. 2 rows, 1 column, 2 and minus 1 are the element. So this is also a 2 into 1 matrix. 2 rows in 1 column, 3 and 2 are the elements. If AB is C, then what is the value of the determinant of matrix A? First, we need to find out X and Y value, then only we'll be able to find out the matrix, the determinant of A in form of numbers. Okay. So here is some condition given, so we can not randomly assume any value of X and Y. Okay, we'll go methodically and we'll multiply A, B. So this is a 2 by 2 matrix, this is a 2 into 1 matrix. So 2 into 1 will be the answer. So x plus 1 into 2, so that becomes 2x plus 2y into 2x plus, okay, first row into first column minus of y. Okay, there is no other column. So second row and first column, 4x minus of x plus y. This is equals to C, 3 and 2. Now we can equate, if there are two given matrices equal, so we can equate their elements. So 2x plus y equals to 3. So this becomes y, right? This becomes 3x. So 3x plus y is equals to 2. Let's subtract both equations. This becomes minus of x is equals to plus 1. So multiplying minus 1 on both sides. So x becomes minus of 1. If x is minus of 1, y will be 3 minus 2x as per this equation. So y is 3 minus of 2 into minus of 1. 3 plus 2, that becomes 5. Y is equals to 5, x is equals to minus 1. Now we have to find out the value of determinant of matrix A. So what is matrix A is x plus y is minus 1 plus 5, 4. Y is 5. 2x is minus 2. X minus y is minus 1 minus 5 minus 6. And what is the value of determinant? Okay, so its determinant will be 4 into minus 6 minus 24 minus into 5 into minus of 2. Minus minus cancels. Minus 24 plus 10 minus of 14 should be the answer. Any doubts, anyone?
No, sir.
Yeah, so it was very easy, just calculative. And in calculations, you have to be deliberate, do not rush. Because a single mistake can cost you negative marks instead of plus. Instead of plus 2.5, you'll get minus of 1.33 or minus of 0.8. Let A be a given matrix of 3 by 3 order, B is a matrix of 3 by 1 order. Then AB is equals to, now we are very sure that the AB will be 3 into 1 matrix. So 3 cross 1 matrix. So this cannot be an answer because this is a 1 cross 3 matrix. There are 3 columns, 1 rows. One option eliminated. Now we know this will, for first row, first column will be multiplied. So the first element is going to be ax plus hy plus zz plus zz. Okay, so this is there in all of the equations. So let's now check for other equations. Hx plus by. Now if there are no other elements, we'll shift to the next row. Second row, first column. So hx plus by plus fy. So okay, so this is there in the plus fz. Okay, this is there in the second, but not in the first. So this option is also eliminated. Now let's look on the third row, first column zx. This is not here. So C is the correct answer. Clear? Any doubts? Very easy question. This was very easy. Simple multiplication question. Any doubts, anyone? If there are any doubts, please ask.
No, sir.
Okay. If A and B are two matrices such that AB is of order n cross n, is square matrix, then which one of the following is correct? So if A and B matrices are getting multiplied, so it is for sure that this here, the order, the number of columns and the number of rows of B are going to be equal. So let's consider them as A. Okay, let's consider as P. Less confusing variable. And if the EB is given as n of n order. So for sure, P and P are going to get cancelled and N are going to remain. So this should be N. Okay. Now let's read the options. And A and B should be square matrices of same order? No, it must not be true. Either A or B should be a square matrix. No, it may not possible. P can be anything. Both A and B should be of same order. No, they are not of same order. Orders of A and B need not to be the same. Okay, yes, this is a good condition. Any doubts, anyone?
No, sir.
So the conceptual clarity will always help in UPSC questions because UPSC is not fond of asking detailed question where you have to analyze question very deeply and use multiple layers of calculation methods to find the answer. They just want you to use by method, like two layer of questions will be there. There will be a concept inside and concept, and the basis will be the basic fundamentals of the question. They are not going to challenge the intellect, or they are just testing a speed and how will you be able to relate concepts and solve questions fastly. Basics are important. How many matrices of different orders are possible with the elements comprising all prime numbers less than 30? 2, 3, 4, or 5? 2, 3, 4, or 6? So how many matrices of different order? Now we have to tell the number of orders that are possible with the elements. So now the number of elements are not given to us. We have to find out how many number of elements are there. So the number of elements are all the prime numbers less than 30. So how many prime numbers are there less than 30? Anyone know? Okay, can anyone tell me what is a prime number?
Um, which has only two factors. One is the number itself.
Good. And other is 1.
One.
Yes. So let's write all the prime numbers. If you don't know, please help me in writing. Okay, we have to write till 30 only. So 5 and 4. Okay. 5 and 5. How many elements are these?
10.
10. So there are 10 elements for the matrix. We have to find the number of orders. We have discussed that we will simply find the number of factors. So let's prime factorize 10. 2 into 5 whole power is 1. So to find it out the number of factors, we'll add 1 on the power and get multiplied. So 2 into 2 becomes 4. It should be the answer. Yes, correct. So there are 10 elements. So 1 into 10 and 10 into 1 into 2 into 5 or 5 into 2. These are 4 possible options. Okay, clear everyone? Any doubts?
No, sir.
Okay. There are bundle of questions. Consider the following for the next two items. Let A and B, these are the matrix of order 3 by 3, with determinant of A as 4, determinant of B as 3. Clear. This is the given equation which will be like applicable for both of the given two questions. So what is the determinant of 2AB It was the determinant of 3AB inverse. So have we discussed the properties of determinant till now? I think we haven't. Anyways, I've written these properties, these are applicable. So the determinant of 2AB, now 2 raised to power n is what? N is the order of matrix. So 2 raised to power n, which is 3 into matrix determinant of A into determinant of B. So 2 raised to power 3 is 8, determinant of A is 4, 3 is, okay, 12 is 96. A should be the correct answer. This is the solution of 239. Let's discuss about 240. So determinant of 3AB inverse. Okay. 3 raised to power 3 into determinant of A into determinant of B inverse. So 3 raised to power 3 is 27. Determinant of A is 4. Determinant of B inverse will be 1 by 3. 3 9s are 27. 9 into 4 is 36. Option number C should be the correct answer. A and C. Okay, clear. So, any doubts, anyone?
No, sir.
Yes, these are the properties. And we will discuss more in determinant chapter in more detail. If A is a square matrix of order more than 1, so it can be 2 by 2, 3 by 3, or any other order, then which one of the following is correct? Determinant of minus of A is equals to determinant of A. Determinant of minus of A is equals to, we have earlier discussed about that the determinant of A, K into A, where K is any constant, is equals to K raised to power N, the determinant of A. So where here K is minus of 1. So minus of 1 raised to power N into determinant of A should be the correct answer. Yes. Any doubts, anyone?
No, sir.
Okay, cool. A is a square matrix of order 3. Now, if it is given that it's a square matrix, so we don't have to write 3 by 3 all the time. So order 3 also means 3 into 3 because it's a square matrix. Okay, anyways, A is a square matrix of order 3 such that its determinant is 4. What is the determinant of its transpose? So note a thing that the determinant of any transpose is equal to the determinant of the matrix itself. So the answer should be C, D. Any doubts, anyone? No doubts because I have already told the property, right? And why it is happening so, you will be able to find out when we'll discuss the determinant chapter in the next chapter class. Any doubts still?
No, sir.
Okay, now we have to find the inverse. For finding the inverse, first let's find out the determinant, but it's of no question because there are matrices in all the options. So let's, instead of finding the inverse, we can go with the simple solution. What is that? We know that the multiplication of A inverse should make identity matrix. So we'll simply find out what is an identity matrix for 3 by 3. 1 0 0 0 1 0 0 0 1, right? So let's multiply this in the option to find out which particular option is giving us this. So let's check for the first element. So cos theta into okay, first row and first column. Cos theta into cos theta, cos square theta plus sin theta into sin theta, so sin square theta plus 0. So this makes 1. So yes, first element is getting satisfied. Let's now check for this particular element. So first row, second column. So cos theta into minus sin theta. So cos theta sin theta plus 0. Sorry, plus sin theta and cos theta. plus sine theta and cos theta plus 0. So this cancels this. 0 is also getting satisfied. Okay, first column, second row, first row, third column. Cos theta into 0, 0, sine theta into 0, 0 into 0. This is 0. That is fine. So I hope this is the right option. Let's discuss this particular element. So second row, first column this time. So minus sine theta into cos theta plus cos theta into sine theta. So these two cancels plus 0 into 0. Okay, great, great. Now let's discuss about second row and second column. Minus sine theta into minus sine theta. So sine square theta plus cos square theta plus 0. So this will also become 1. Great. This is the confirmation. This must be the answer. Let's see. Second row, third column, 0 into 0, 0 into 0. Sorry, 0 into minus sine theta, 0 into cos theta, 0 into 0, 1 into 0. So this is 0. So third row, first column, 0 into 0 into 1. So 0 into cos theta, 0 into sine theta, plus 1 into 0, 0. 0. Now, third column, second row, 0 into minus sine theta, 0 into cos theta, 1 into 0, 0. 0 into 0, 0 into 0, 1 into 1. 1. So all the elements are getting satisfied. For sure, A is the answer. So see how using options only we have find it out the inverse of any given matrix, right? But UPSC has also come to learn. They have stopped asking this simple question. They now ask by tweaking a question a little. Okay. But can solve question using this method also. Yes, A is the correct answer. Any doubts, anyone, how we have solved?
No.
Yes, using a simple property, we know that the multiplication of any matrix with its inverse is identity matrix. And this was our good luck that we find it out everything, and everything was uh, getting, and we got the answer in the first option itself. So maybe they also wanted us to hit and try and just take the option. Anyways, if we would have gone with this option, let's say first row, first column, then cos square theta plus sine theta into zeros. So this becomes cos square theta plus sine theta into 0 plus 0 into 0. So this becomes cos square theta instead of 1. So simply by checking this first row and first column itself, we can eliminate this option. Now let's discuss about the next option. First row, first column, cos theta into 1, sine theta into 0, 0, 0 into 0. So this has become cos theta instead of 1. This can also not be the right answer. First row, first column, cos theta into cos theta. Okay, cos square theta. Sine theta into minus of sine theta, minus of sine square theta, 0 into 0. Instead of becoming 1, it has become cos 2 theta. Another, we can eliminate like this also. So it's not just that we have solved for the first option, we are having good luck. No, otherwise also we would have eliminated these options with simple calculation. Clear, everyone? Are you able to understand what I'm trying to say? Hello, hello, is everyone awake? Anyone awake? Everyone slept.
No, sir. Yes, sir.
Yes. Do you want like break for few minutes or shall we continue?
Few minutes, sir.
Okay. So 3 minutes will be enough, right? Or
Yes, sir.
more.
It's enough.
Okay. So 10:41 will continue. Wash your faces. Next question. A is a given matrix. We have already discussed. This question is repeated. This particular matrix has repeated. A square. That's y a square. There's a matrix A given. We have to discuss about A square. And when we observe all the options, A square is there in left hand side. So let's discuss about A square itself. Okay. So minus 2, 2, 2, minus 2, minus 2, 2, 2, minus 2. First row, first column, minus 2 into minus 2, 4, plus 2 into plus 2, 4. Then the first row, second column, minus 2 into minus 2, minus 4, plus 2, minus 2, minus of 4, plus 2, minus 2, sorry, plus 2, minus 2, minus of 4, minus 2, plus 2, minus of 4, plus 2, plus 2, 4, minus 2, minus 2, plus 4. So this will become 8 minus 8 minus 8, 8. Okay, cool. So this is A square. What was given to us? Let's take 4 common. So after taking 4 common, this has become 2 minus 2 minus 2, 2. This is equal to A matrix. So this is A square is equals to A square is equals to 4 of it. Now, no. There is also a minus 2 sign is with the principal diagonal elements. Let's take minus of 4 common. Now this has become minus, this has become plus, this has become plus, this has become minus. So minus of A square is minus of 4A. Any doubts, anyone?
No, sir.
Great. So now we have to find out the adjoint of this given matrix. So we'll simply write the matrix. Now let's repeat the first 2 columns. Now let's repeat the first 2 columns. Sorry, first 2 rows. This is 0. Cancel the first row, first column. Now rewrite the matrix whose transpose will be the adjoint of A matrix. So 1 into 1 minus 3 into 0, 1. 0 into 0 minus of 2. 2 into 3, 6 minus of 0. 6 into minus 0. 1 into 1 minus 0. 0 minus 3. 0 minus 2. 4 minus 0. 1 minus 0. Okay, now we have to take its transpose. Okay, don't forget this step. So the adjoint of A is 1 minus 2, 6. This was the first row. 6, 1 minus of 3. Second row. Third row is minus 2, 4, and 1. We also have to find out the so only the adjoint was needed to find out. 1, 6 minus of 2. 1, 6 minus of 2. What is this? 1, 6 minus of 1, 6 minus of 2 is the first row. Oh, yes, 1, 6 minus of 2. B should be the correct answer. Yes, it is the case. Now, in objective type questions, we just will not be finding all x's. Let me resolve it for you. Let me resolve it. Will not find these much. After writing this, simply write matrix. Then we'll solve this 1 minus 0, 1, 0, 0 minus 2, minus 2, 6 minus 0, and its transpose. So the first column should be 1 minus 2, 6. Now let's look for in the options. No, there should be plus 1. Option eliminated. 1 minus 2, 6. This can be an answer. Okay, this is also eliminated. This is also eliminated. All three options are eliminated. But this must be the answer. B is the correct answer. Without solving much. That's how partial solving and selective solving works. And this is how you can solve questions fastly. Right? Any doubts? Any contradictions? Should I explain it once again? You have only find it out one row. So it's transpose. So first row will become the first column, and there will be other elements as well. But we have just matched the first column, this first column, which matched with option number B only. So that's why we are able to conclude that B is the most appropriate answer. Clear? Any doubts, anyone?
No, sir.
Okay. A, B, C are non-zero real numbers, then inverse of the matrix A is equal to. Now we know that the inverse of any diagonal matrix is a diagonal matrix only. So all the given matrices in the options are diagonal. Okay, let's find out its determinant. So its determinant is simply ABC, but still let's find it out. A into BC minus 0, minus of 0, anything doesn't matter, plus 0, anything doesn't matter, because uh, anything getting multiplied with 0 is going to become 0 only. So ABC, yeah, 0 minus of 0, 0, 0, 0, doesn't matter. So the determinant is ABC. Now let's find out the adjoint of the scene. A 0, 0. We are finding adjoint of A. 0, B, 0, 0, 0, C. A 0, 0, 0, B 0. Repeating the first two rows, A 0, 0, A 0, 0, B 0, 0, B. Cancelling first row and first column. Now, okay, so BC should be the first element, and this 0 into 0, 0 minus 0, 0, 0 minus 0, 0. So let's find out the first row only, its transpose, and then the adjoint of matrix A becomes, its first column will become this, and we don't know about else. For finding inverse, we'll divide the adjoint by the determinant, which is ABC. We'll divide it by ABC. So let's divide the first column because we don't know about the else. So if we divide it by ABC, what will be left? 1 by A and 0, 0, of course. So this element should be 1 by A. Now it is 1 by A here, but here this is not 1 by A. 1 by ABC is also there. So this is not the correct answer because here the first element is 1 by A into ABC. So it's like A 1 by A square BC. Here also 1 by ABC is the first element. Here also 1 by BC is the first element. So only by solving one row of that joint, and then because one column of that joint, we are able to find out its inverse. This is a short method. You need some brain, and I need some power of expression to express and to make you understand what I am doing. So if I am failed to make you understand, please tell me, I'll repeat. This is important, that how am I solving this question, because it's speed that is required in paper. So please learn the method. If you have any doubts, I can clear it. Please read for once. Done reading? Yes.
Yes, sir.
Any doubts, anyone?
No, sir.
Yes. Okay. Let's go ahead. If A is a square matrix, then the value of adjoint of A transpose minus of adjoints A transpose. We know that the adjoint of A transpose is equal to the transpose of adjoint of A. So if they are both equal, they are going to cancel each other. So if they are going to cancel each other, it's going to be null matrix. C option should be correct. Of same order, that is one thing of importance. Clear? Any doubts, anyone?
No, sir.
And if there is a matrix, let's say A, B, C, D of 2 by 2 order, how will you find out its adjoint? We'll simply exchange the principal diagonal elements and change the sign of the meaning. As easy as that. So if you forget any property, if you are not able to do it, simply consider a matrix that this is the matrix. Okay. So the adjoint of this matrix is this. Now the transpose of this matrix is A, B, C, D. Now let's find out the adjoint of this A's transpose. Now we'll exchange the principal diagonal elements and change the sign of these. Okay, so now we able to find out that adjoint of A is equals to adjoint of A's trans. Now wait a minute, wait a minute. Oh, now what we are discussing about adjoint of A's transpose and adjoint A's transpose. So let's make it transpose. Okay, let's find out its transpose. So adjoint of A whole transpose. So the first row becomes the first column, second row becomes the second column. Now, are they the same? Yes, they are the same. So this is how also you can take any example and find out the same. And please take an example of 2 by 2 matrix only, because that's easy to solve. Clear, everyone?
Yes,
Yes?
sir.
Okay, so I guess there are no more questions. This finishes our matrices chapter. Please try to solve questions of this chapter. If you have any doubts, we'll cover the same in the next class. And also the same determinants chapter. So you can read that chapter for the class as well from your textbook. Okay. I'll share the PDF of the today's class in the WhatsApp group. Study, self-study is important. Please find time to self-study, revise notes, solve questions. Then only you'll be able to make a better understanding of the concepts. Yes?
Yes, sir.
Okay. Thank you, everyone. Jai Hind.